Hey, what's going on? So I've been publishing little bits and pieces of this solar tracking project for a little while now, and I want to try and gather all my thoughts into one video. So here's the attempt to do that. The panels I chose to use, non-tracking and tracking, they're not exactly matched. So they ended up giving me data. I mean, they're from similar products, but they're just not exactly the same. This is the rough setup here. I'm not using LEDs anymore. So it's basically just being shorted across a resistor. This is a 212, I think now, on both sides. And then into an Arduino. So that's what's going on there. But because the panels are matched differently, and I'm cheating here, I'm just skipping the editing phase and using a bunch of data that's already out. A little short on time. So this is what the panels give how they are. So I set them both to be stationary, facing the same way. And this is basically a full range drop of the sun here, a sunset. And so you can see in full sun, this one's giving out quite a bit more. And what you can't see is it does actually dip down below the other one here. So I needed some way to calibrate those to output the same thing. I mean, obviously I could go get different panels, but I chose to do it software. So what I used was, it's really dirty. This is a dirty way to do it. It's not exact, but whatever. I used the map function from Arduino. So basically what I did, I'll move this to the side here so you can see, is used this value. This is the stationary panel here. So whatever value that was returning, I wanted to get an integer, a divisor. What do we call it? An exponent. I don't know. I don't know what word I'm looking. A number. I needed a number from here. So what I did is mapped that range. So ordinarily, the way that the syntax works, you give the first value and then the first range and then the range you want. So originally it ranges from 1 to 650 or so in full sun, and I wanted it to return what would end up being a percentage value. So on the bottom end, you can't tell, but it's actually about 0.7, 0.73 or so times compared to the other one, and then in full sun it's about 1.5 times up here. So if you follow me, then this is what this whole video is about, and it's just fun, dirty calibrating. That's what I used to come up with a number, a percentage number basically, and then multiply this by that number, and ended up with, let's see here, something that looked like this. So again, blue is the original data, and this is the same day, same set of data, and the orange is the adjusted value with that map function. Gray is the number it's multiplying it by. So here's 100, which would be 1 or whatever. I move the zeros around a little bit. I play with the decimal points a bit. And then as it gets lower, the value it multiplies it by gets lower. And this is basically the error. And it's pretty much bang on 100 or so most through the day. And then as it gets lower, it gets tougher to regulate. So that's how I got my numbers. And then I started actually setting the panel to track. Right? I'm getting ahead of myself here. So this is the first full day of data here that I got. Lots of clouds. You can see this is the change. This is basically the delta value, one minus the other. I don't know if that's delta. That's not right. You can see there's a pretty clear trend here, right? So this would be, I call that the gains curve. That's how much more the tracking panel is outputting. And again, at the beginning of the day here, there was quite a bit of clouds. Plus, my house is cut off from the initial sunshine, from the sunrise, so I wouldn't get all the sun in the beginning. So this curve, you can imagine, would come up quite a bit more if I had more exposure to those times. So my next day, where I got almost a full day, was this one. You can see the sun came up a little bit earlier without clouds, so that curve was did come up and be a little more established on that side. But I ended up with rain at the end of the day. So, but the gains in the daytime, of course, are not very much. The panels are facing pretty close to the same direction, but this is where it really matters, right? Is on the ends. So I did a little rough sketch to see, you know, this is basically what I would imagine it would look like if I had full sun all day. Just continued the curves basically. It's off, but you can get an idea of that. So this is where solar tracking proves to be beneficial. Early and late kind of seems like the obvious, obviously that's what it would be. But this is where it really, like, it hits the road, right? Where the rubber hits the road. So if you want to get gains out of your solar tracking system, then you have to have access to early sun and late sun. If you don't, if you live in a mountainous region or you're surrounded by buildings or trees or something, you're not going to get this. You're just going to get this little bit of a gain. Now, that's granted, that can be a good 10% gain or so, but with the addition of these bits at the ends, that's where it really pays off. So I live in Alberta, Canada. It's pretty flat on one side. This would be the Rockies to the west of us here. The Rocky Mountains do cut off a bit of sunshine, so I'll get a bit lower of a number here than I would here if I had full access to the horizon line. Basically, it's really flat here, so I would get like a huge degree of sun through the day, and this would be really high most of the day actually. Like it tops, it's amazing how quickly the tracking tops up. So that's basically what I learned from this is situational, right? But a solar tracking system can be hugely beneficial. So I did a rough bit of math here. I'm not going to talk you how I went through this. It's just stupid. So I did some triangle math and came out with about 26% increase. Very rough, of course, but that's quite a bit. When we're talking about, you know, a rate of return, which is where people really start to talk about, well, is this worth it? How quickly can I make my money back? That's a lot of people's bottom line. Doesn't matter how good it works or what it is, how quickly can I get my money back? Well, 25% faster is quite a bit, right? Now that's in ideal conditions, but I would like to point out that even in non-ideal conditions, like here when the clouds are coming through, that stays pretty consistently better. And the question that I always get asked is, well, how much power are the motors using? That is something that's going to have to be sorted somewhere else. Now, obviously, there is a formula for that, right? But basically, if your motors use up more power than you are going to consume in a day by simply tracking one direction, like a full range of the motors in each even twice. So say you move your full range of your motors one way and then back up and then down to account for any jitter or anything like that. If doing that uses more power than you're going to consume or than you're going to gather in a day, then you have designed your panels wrong. I know that there is an equation for that, obviously, but that's always a big concern, is, well, how efficient is it? Is it worth having the tracking? I guess you can use that 25% roughly number to figure that out. If you're going to use more than 25% of the power that you gain in a day by moving those motors, you're going to be moving a huge panel. Wind shear is probably the last thing I'd like to talk about as well. If you're going to have a panel out in the open where it can see the sun, you're going to have wind shear, and the larger panel you have, to account for larger motors or whatever else you're doing, you're going to have more and more wind shear. So that is something else to think about when you're engineering your tracking panel. So just a little bit of data there. I know it's kind of here and there, but that's at least gathered in one place for anyone interested. And any more questions or anything, let me know. I'm going to continue on with the larger scale version because I do live in Alberta where I do have access to some horizon lines. Maybe not on my property, but I know a couple people that are going to be able to benefit from a full-size tracker. So there we go. Cheers.